arc length is a portion of a circle's circumference. It's not the whole circumference, it is part of it, okay? So if we wanted the entire circle's circumference, what would the formula for that be? 2 pi r. Okay, so circumference is 2 pi r. So to make the formula for arc length, we kind of have to think about, like, how could I take something and do just like a portion of the circumference? I want to find like a percentage of that, okay? So when you find a percentage of something, you do a part of something out of the whole of something. Does that make sense? You do a part out of the whole. So over here, we're going to say that this angle right here is theta, because they often use theta to describe angles. Theta, it's a little circle with a line through it, theta. It's a Greek letter, but they often use it to describe angles. Does that sound familiar from when you guys learned trig? Theta? Nobody ever used theta? Feta? Feta cheese? Yep. Very, very similar, yeah. So theta, it's a circle with a line through it. If this is your first intro, don't worry, it's going to keep happening. So theta is the typical variable that is used to represent angles. Pretty common. So theta is just what we're going to go ahead and use when we write this here. So theta is like the specific angle, but how many degrees are in a whole circle? 360. So we're going to say that the whole circle is 360 degrees. And then the part of the circle that we're talking about is going to be theta degrees, however many degrees that happens to be. Does that make sense? Okay. So what we do is, if we want just a little portion of the arc length, and the arc length, the way that you write it is you say AB with the arc over it, right? AB, the arc length AB. We're going to say that the formula to find the arc length is theta over 360 degrees multiplied by 2 pi r. So this is kind of like saying I'm taking a percentage of 2 pi r. I'm taking a percentage of 2 pi r. So if it was 45 degrees, then you would say 45 degrees out of 360 degrees, that portion of the circle out of the whole thing. Or if it was 90 degrees, 90 out of 360 is 1/4. So I'd say I'm taking 1/4 of the entire circumference. Does that make sense? Or if it was 180 degrees, I'd say 180 degrees out of 360 of the entire circumference. I'd be taking half of the entire circumference. So you're just saying I'm taking a percentage, or I'm taking a portion of the entire circumference. That's how the formula works, okay? Another way you can see it written is maybe they didn't use the angle here. Maybe instead of the central angle, they used the measurement of the arc. The measurement of the arc. So they could also write the formula as the arc length AB is the measurement of the arc divided by 360 times 2 pi r. It's exactly the same thing. It's just kind of using circle conjecture 1. So this is kind of like the formula in terms of the central angle. This is the formula in terms of the arc, the measurement of the arc. They're the same thing. It's just that sometimes they tell you the degree measure of the arc, sometimes they tell you the degree measure of the angle. Same thing, okay? Any questions? How do your brains feel? Brains are good? Brains are okay? Okay, so let's do a couple of these, and then we'll look at sector area. So if we go down to the picture, it says we have circle E, and whenever they talk about circles, they always name them based on their center. So the center of the circle is E, so they're going to call it circle E, where the angle TEG is 21 degrees. TEG is 21 degrees. TR is a diameter, and the diameter has a length of 12. So if the diameter is a length of 12, then what's the radius? 6. Okay, so I'm going to write radius equals 6. Okay. Fill out the table using exact measurements in terms of pi. Okay. So exact measurements in terms of pi. They want us to find the arc measure for all those different arcs. So I'm going to go ahead and kind of label everything. We have central angles for this whole picture. Okay, so this is a diameter. It goes all the way across the circle. So what does that mean about how many degrees are in this whole piece right here? 180. So if this is 90, what's this? 90. Okay, that's 90. And if this is 21, how could we find all of this? Yeah. You're close. 180 minus 21. So 180 minus 21 is... So 159. 159, okay. All right. And then they want us, instead of letting us write it in terms of the angle measure, they want us to write all of these as the arc measure. So these are all central angles, so we can go ahead and put the arc measures, just they're exactly the same as the central angles. So 90 degrees, 90 degrees, 21 degrees, 159 degrees. Okay? All right, so the measurement of the arc from T to G, we can already see that that's 21 degrees. Okay, from A to T to R. A to T to R. How much is that? 270. Okay. All right, from T to A to R. 180. Okay. From A to R to G. 249. Okay. And then from A to R. Okay. So now we're going to go ahead and do the arc length. So to do the arc length, we just have to do the measure of the arc divided by 360 multiplied by 2 pi r, and they want us to leave the answer in terms of pi with exact measurements. So we're going to do 21 over 360 times 2 pi, the radius is 6, times 2 pi r. Okay, so when I type this in, I'm going to type everything except for the pi because we're doing exact measurements, and so the pi doesn't get typed, it only gets written down. So 21 over 360, 2 times r. Oops. So that's what I'm typing. 7/10. And then because I did not type the pi in the calculator, I write the pi in my answer. 7 pi tenths. Now, the length was in terms of centimeters, and this is an arc length. It's not an area, it's a length. And so my units are going to be centimeters. Centimeters is going to stay centimeters. It's not going to become squared, it's not going to become cubed, because we still have a dimension of 1. Does that make sense? Yes? No? Yes? Okay. All right, the next one is going to be 270 over 360 times 2 pi 6. So 270 over 360. Okay, so that one's just going to be 9 pi centimeters. Okay, and then we have 180 over 360. All right, this one is 6 pi. Okay, 249 over 360. (83/10). So 83 over 10, I'm going to stick the pi on top, 83 pi tenths. And then last one is 90 . Okay, 90, so just 3 pi. Okay. How do you guys feel so far? Pretty easy to type in. We can use the formula. The formula makes sense. We can see where it comes from. Okay. So what I want you guys to do now is you guys are going to help me come up with the formula for sector area. I was trying to remember, I think there is some sort of shorthand for sector area, but I honestly couldn't remember what it was. So we're just going to use SA for sector area because I honestly can't remember. And when I Googled it before class, I could not find it quickly. So we're going to say, there's the angle. So if I want the sector area, actually, let's back up for a second. Somebody remind me, what's the formula for the area of a circle? Pi r squared. The area of a circle is pi r squared. Okay, you're welcome. So if we want the sector area, then that is going to be just the area of the sector. So I think of it as like the area of like a piece of pie or a piece of pizza. So that's what that is. So before, and actually, if you have a pen or something, this could be good. Before we were finding the length of the arc, this is what we were finding before, is like how long that was. And then here we're actually finding this area, if you want to like kind of differentiate between these. Anytime we can color our notes, it's a good day, you know? Okay, so that's the difference between the two formulas. One is finding the length right here, and then the other is finding the area. So if we were to write the formula for the sector area, how do you guys think we would write the formula? We call this theta. Theta, theta. So how would I say it? What would I write for my formula? It's very similar to the last one. Yep. Theta over 360 times pi r squared. Theta over 360 times pi r squared. So if they give you the central angle, you can think of it that way, or if they give you the measure of the arc, then you can think of it this way. It's the exact same thing. It just kind of depends on how they phrase it in the question. So you can think of it as the measure of this angle right here, or you could think of it as the measure of the arc. But we know, because we've already learned circle conjecture 1, we know that those measurements are the same. So it doesn't really make a difference. But they could phrase it either way. So how should we take all of these problems that we just did and find the sector area instead of the arc length? How are we going to change it? Mm-hmm. Perfect. So keep all the fractions you had in the front. All those are going to stay the same. And then after that, we're just going to do pi 6 squared. Okay. So in the calculator, I'm not going to type the pi though, because I'm doing exact answers. So 21 out of 360 times just 6 squared. And I'll just stick the pi on my answer. So 21 pi over 10, and then because this is an area, what should my units be? Centimeters squared. Okay, so the next one is going to be 270. Okay. Yeah. Mm-hmm. Which makes sense because you're doing 2 times 6, which is 12, and 6 squared is 36. So it specifically has to do, that's not necessarily going to be true every time. It is specifically because our radius happens to be 6. You're going to see a relationship every time, but it won't always be 1/3. It'll always be something. Like if we had, let's say our radius was 8, then it would be 2 times 8 is 16, and then it'd be a fourth. Then 8 squared is 64, so it'd be a fourth. Interesting. Yeah. So there'd always be a relationship, it just wouldn't be consistent. Yeah. All right. Next one says, what is the approximate length of the arc ARG if you round to the nearest thousandth? So at this point, they're just saying take the formula, but if we're rounding it to the nearest thousandth, we're not leaving it in the exact form, we're not leaving pi in the answer, we're actually plugging pi into the calculator, and we want the whole decimal answer. So we're going to do 249 over 360. And we're actually going to type in 2 pi times 6. We're going to type the pi in. So if the pi is not written on your calculator, or if the pi is not written on your paper, then it gets written in your calculator. It's either one or the other. So 26.075 is what you should get. All right, and then it says, what is the approximate area of arc TG rounded to the nearest thousandth of a square centimeter? So TG was the first one, so we've got 21 over 360 times pi r squared. So we're just typing that one back in, but we're typing it in with the pi. So pi 6 squared. Typing it in because we want the decimal this time. And what do you guys get? Perfect. Okay, cool. And then the units are centimeters squared. So the formulas are pretty easy and straightforward. Some of the problems are just as easy and straightforward because they're just asking you to plug numbers in, get an answer out. And then some problems, the ones that are like EOC type multiple choice, they can make these like really creative type problems where they make you think about how you're going to use the formulas. So what I'm going to do is let you guys practice some of the straightforward problems first, get yourself used to the formulas, and then I want us to try some of the ones that are kind of funky together so we can see like, okay, when they start to mess with our brains, how do they do it? So we kind of have some strategies to deal with those. All right, so these problems, the picture kind of matches the first page when they were asking you to find the length of the arc, the length of AB. So if you look at this, you can see that what they did in the picture is they labeled the radius. They showed you like the radius of this picture is 12 centimeters, and then they labeled the length of the arc. So they're telling you that the arc length is 12.56, and they want you to find the measure of the arc AB, which means they want you to solve for that theta value, or they want you to find like the central angle, the measurement of the arc, same idea. So if you need to show this, you can just kind of show like, okay, this is the measurement they gave me, this is the measurement they gave me. So we're kind of doing the backwards version of the problem, is basically what we're doing. So we're using the arc length formula. So we're going to say the length of the arc is equal to the measurement of the arc divided by 360 times 2 pi r. That's the formula. So what we're going to do now is we're just going to plug in all the information we have and then figure out what we're solving for, and then we can actually solve for it. So they want us to find the measure of the arc AB, and that is kind of cumbersome to write. That's a lot of letters, so I'm just going to say that's going to be my x value. I'm going to find x, and that shows up right here, and so I'm going to call this x. Are you guys cool with that? Letting that be x? Okay. So the arc length on the first one is 12.56, so I'm going to say the arc length equals the measure of the arc, so the degree measure of the arc divided by 360 degrees, times 2 times pi times the radius. And then at this point, all we have to do, now that we've plugged the numbers into the formula, all we have to do is try to get the x value alone. So what's the first thing that you would like to undo near the x? Yeah. Yeah, so it's divided by 360, so we could go ahead and times by 360. And that's not the only first thing you could do. You could undo the 2 pi 12 if you wanted. So 12.56, we are multiplying by 360, so our 12.56 is going to get pretty big pretty fast. So we have 4521.6 equals x times 2 pi 12. Okay. And so at this point, how do we get rid of the numbers that are by the x? We divide by those numbers. And you don't have to divide by them one at a time. You can divide by them all at once. You just have to make sure you type it into your calculator correctly so you don't get the wrong answer. So divide by them all at once. Divide by them all at once. So if I want to do this, I either have to put the bottom in parentheses or I have to type this as a fraction. If you don't put the bottom in parentheses or you don't type it as a fraction, then your calculator will think that you're multiplying something, okay? So I'm going to type it either as 4521.6 divided by, and then put this in parentheses. I can do that. Or I can type it in like this, and then 2 pi 12. Those are both good options. I should not type it in this way, because what my calculator is going to do is it's going to think that I'm dividing by the 2 and then multiplying by the pi and multiplying by the 12. So I'm going to get the wrong answer if I type it like that. Okay? So make sure that you divide by all of those things by either typing it as a fraction or putting parentheses on the bottom. So the correct answer is, they want the approximate answer, so you can go ahead and just put the overall degree measure. This is approximately 60 degrees. Very close to 60 degrees. So we're going to go ahead and just say the angle was 60 degrees. That's what we're going to do. I'm going to go back and say measure of arc AB is approximately 60 degrees. And the thing is, you don't even really have to say measure of arc AB. You could literally just write 60 degrees, put a box around it. That'd be fine. Okay, does that make sense? We're okay with that? All right, let's go ahead and flip the page, try the next one. So the next one is the exact same thing. They just are giving you the sector area instead of the arc length. So here we're going to have the sector area formula. So we have the measure of arc AB divided by 360 degrees and then times pi r squared. So again, they're asking, the instructions are the same for this problem as well. So they want us to solve for the measure of the arc. So I'm going to have an X here. They want us to solve for the measure of the arc. And which one do you guys want to do? 22, 23, 24? 23, let's do 23. Okay, so we're going to say the sector area is 506. And so that's going to equal the measure of the arc divided by 360 times pi times r squared. And what should we do first? What should we do first? Okay. So 506 times 360. Okay, and then what should we do? Okay, divide by pi 20 squared. And just make sure that you type that in correctly. And when you do type that correctly, what do you get? Yeah, 144.9, blah, 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 blah. So approximately 145 degrees. Okay. After that, there's a series of multiple choice questions, and the multiple choice questions are saying, okay, you're used to the formula. Now we're going to make you prove that you're in Honors Math 3. Okay? So let's move on to number 25. What I have found is that the best way to do these problems is to start off with the formula, and then to put the things in the formula and then figure out how to solve it. So we have to look at the problem first to determine, should we be using a length formula or should we be using an area formula, okay? So if you look at number 25, it says in circle B, the circumference is 72 millimeters and the length of the minor arc is 6 millimeters. What is the measure of angle CKA? So if you look at that problem, should we be using the arc length formula or the sector area formula? Length. They mentioned length twice. Did you guys notice that? They mentioned circumference and then they mentioned length. So we are not using the area formula, we're going to use the length formula. So I'm going to go ahead and write that first. I'm going to say the length equals the measure of the arc divided by 360 times 2 pi r. And then once I have my formula written down, I'm going to start to plug in the things that I know. Okay? So what did they tell me in the problem that I could start to plug into the formula? In the circle below, the circumference is 72. The length of the arc is 6. The circumference is 72. The length of the arc is 6. Yeah, the 2 pi r, this whole thing is literally the formula for circumference. So that whole thing we're going to take out, and we're just going to replace it with a 72. We're not going to have a pi in this problem because we're replacing 2 pi r with a 72. So I'm going to say this is going to be a 72. Okay. What else can we take out and replace? What else did they give us? They gave us the arc length. What did they tell us that it was? 6. Okay. So what are we apparently solving for then? The x, which is what in the formula? The angle. So apparently we have enough information to find the angle to find the measurement of the arc. Does that make sense? Okay, so we're going to find that first. That's what we have the information to find. Okay, so what should I do? Okay, times 360 times 360. 6 multiplied by 360 is 2,160, and that equals x times 72. Then what should I do? Okay. Okay, so now let's go ahead and label in our picture what we just found. So can somebody tell me what I should be labeling? What did I find? Did I find angle K? This angle all the way back over here? I didn't find that. What did I find? Angle B. Okay, so this angle right here is 30, and then this arc right here is also 30, because those are always the same. That's what I just found. Now, the problem wasn't asking for that, were they? What was the problem asking for? The problem said the measure of CKA. So C to K to A. That's what the problem wanted. So what's CKA? 15. CKA is an inscribed angle, so CKA is 15. So I start off by recognizing which formula to use. I plug in the information I have, I solve what I can solve for, and then I go from there. Does that make sense? Okay, let's try another one. We're going to flip the page, and we're going to look at number 28. Now, if you guys notice, like all of these pictures, they have this exact same picture 3 times. None of them are drawn to scale, so don't get mad when the problem looks dumb because they literally copy-pasted the same picture over and over. The place where I got these problems, they did not have any other picture. They just had that picture. Okay, so it says in circle O, the length of the arc is 6 pi inches, and the measure of COA is 120 degrees. What is the radius of the circle? So based on the information given, are we finding a length? Are we using the length formula, or are we using the area formula? Length or area? What did the problem say? Length or area? Length. They use the word length, so we're going to use the length formula. So we're going to say arc length equals the measure of the arc divided by 360 degrees times 2 pi r. And now we get to start plugging in the things that we know. So what did they tell us in the problem? Okay, the length of the arc is 6 pi, so I'm going to take the AB out, the arc length AB out. I'm going to put 6 pi in there. Okay? 120 is the angle measure, which is going to be exactly the same as the arc length. So if I wanted to label that in the picture, I could. This is 120 degrees right here. That means that this is also 120 degrees. They're exactly the same. So 120 degrees divided by 360 degrees. Okay? And then all that we have left is a variable r, and that's what we're solving for. That's what they said. That's the only information we have left, and that's exactly what they're asking us to find. What is the radius of the circle? So 2 pi r. Okay. So what do you guys want to do first? Yeah. You can cancel out the pi's. There's one on each side, so we can just get rid of them. Okay. Pi's are gone. What else could we do? We can multiply the 360 over, okay? So times 360 times 360. So 6 multiplied by 360 is 2160, and that equals 120 times 2r. Okay. Okay. Do you want to divide the 120, or should we deal with the 120 and the 2 at the same time? Yeah, we can do it separately. Could we do it together? How would we do it together? Yeah. So what should we divide by? 240. Yeah, the 120 and the 2 make 240. So we could just go through and just divide by 240. But you can also divide them separately and you're still going to get the right answer. Either way, you're going to get the right answer. So 2160 divided by 240 gives you that the radius is what? 9. The radius is 9. Okay. So from this packet, you are going to do all the problems up to 29, 1 through 29. Anything after 29, if you choose to do it, is extra credit. So 1 through 29. Just regular, just homework extra credit. Yes, you need one of these. Okay. And then make sure that when you guys are done with this, you're also working on your quiz review.